Anticipated $10 trillion market disruption across key sectors by 2030. Overview. The impending technological revolution in robotics and automation is set to redefine the global economy with an estimated market disruption worth $10 trillion across 5 critical sectors: manufacturing, logistics, agriculture, healthcare, and retail by the year 2030. This transformation is projected to yield efficiency gains of about 25%, fundamentally reshaping the operational landscape and positioning companies like Tesla as leaders in the burgeoning global robotics industry. Key trends and developments. 1. Technological innovation in robotics. The incorporation of artificial intelligence (AI) into robotics is a cornerstone of this transformation. The International Federation of Robotics (IFR) emphasizes 3 types of AI driving this change. Analytical AI for data processing, which enables robots to analyze past tasks and optimize their performance. Physical AI, allowing robots to simulate real-world environments and learn through experience rather than explicit programming. Generative AI, which is anticipated to revolutionize the capabilities of robots across various applications. 2. Shift to humanoids. Although humanoid robots have attracted considerable media attention, the practical applications in industry remain focused on single-purpose robots. The automotive sector leads in the deployment of these robots, but the economic feasibility of broader humanoid robot applications is still under scrutiny compared to existing industrial solutions. 3. Sustainability and energy efficiency. As global sustainability goals gain prominence, robots play a pivotal role in enhancing production efficiency. Innovations in robot design, including the use of lightweight materials and energy-efficient components, contribute to a reduced environmental footprint. Robots are increasingly being utilized to help manufacturers meet the United Nations sustainability targets by minimizing waste and improving the output-input ratio in manufacturing processes. 4. Emerging business models. The traditional manufacturing landscape, particularly among small and medium-sized enterprises (SMEs), holds significant potential for automation. The introduction of robot-as-a-service (RaaS) models allows businesses to leverage robotic technologies without the burden of substantial initial investments, thus expanding the market for automation solutions beyond manufacturing into sectors like construction and warehousing. 5. Addressing labor shortages. The manufacturing sector faces acute labor shortages due to demographic shifts, particularly in developed nations. Robotics can alleviate these shortages by automating repetitive and hazardous tasks, enabling human workers to focus on higher value activities. The development of collaborative and mobile robots is facilitating this transition, enhancing productivity and efficiency. Common themes across sectors. The pervasive narrative across these sectors emphasizes the transformative potential of robotics and automation in boosting efficiency, sustainability, and addressing labor market challenges. Key themes include the integration of AI as a driver of operational efficiency, emerging business models such as RaaS that lower barriers to entry for automation, the critical role of robotics in achieving sustainability goals and mitigating labor shortages. Industry-specific insights. Manufacturing. The manufacturing industry is expected to lead the automation revolution. The IFR reports that the global market value for industrial robot installations has reached an all-time high of $16.5 billion, with demand driven by technological advancements and the need for improved efficiency. Logistics. Automation in logistics is anticipated to streamline supply chains, reduce operational costs, and enhance delivery speeds. Innovations in autonomous vehicles and drones are set to redefine logistics operations, enabling more efficient goods transportation. Agriculture. Robotics in agriculture is revolutionizing food production through precision farming techniques. Automated solutions are helping farmers increase yield while minimizing resource usage, aligning with sustainability goals. Healthcare. The healthcare sector is witnessing the integration of robotics in patient care, surgical procedures, and administrative tasks. Robotics can enhance patient outcomes while addressing workforce shortages in the healthcare industry. Retail. In retail, automation is transforming inventory management, customer service, and checkout processes. Robots can handle repetitive tasks, allowing human employees to focus on customer engagement and strategic decision-making. Timeline of events. 2025, the anticipated peak in industrial robot installations is projected to reach $16.5 billion, highlighting the growing demand for automation technologies. 2030, the expected realization of a $10 trillion market disruption with a strong emphasis on efficiency and automation across multiple sectors. Conclusion. The convergence of advanced AI technologies, innovative business models like RaaS, and the pressing need for sustainability and labor solutions underscores the transformative impact of robotics on the global economy. As companies like Tesla position themselves as leaders in this field, the anticipated disruption across manufacturing, logistics, agriculture, healthcare, and retail is poised to create a new era of productivity and efficiency, shaping the future of work and industry. The evolution of robotics is not merely a technological shift, it represents a fundamental transformation in how industries operate, compete, and thrive in a rapidly changing world. The anticipated market disruption of $10 trillion across manufacturing, logistics, agriculture, healthcare, and retail sectors by 2030 presents several counterintuitive insights that challenge traditional perceptions about the evolution of these industries in the face of automation and robotics. 1. Focus on single-purpose robots over humanoids. While humanoid robots are often portrayed in media as the future of robotics, the reality is that most industrial applications remain centered on single-purpose robots. This counterintuitive finding suggests that despite the fascination with humanoid forms, the practicalities and economic considerations of existing single-purpose robots are far more advantageous for industries that prioritize efficiency and cost-effectiveness. The automotive industry's pioneering role in robotics illustrates that the current market demand is for specialized robots that can handle specific tasks rather than versatile humanoid robots. 2. Sustainability as a driving force for robotics. It may seem counterintuitive that robots often associated with increased industrialization and energy consumption are actually being leveraged to meet sustainability goals. The integration of robotics is enhancing production efficiency, minimizing waste, and complying with environmental regulations. This challenges the perception that automation inherently leads to negative environmental impacts, instead positioning robots as crucial players in achieving a more sustainable industrial framework. 3. Robot as a Service RaaS models. The traditional view of robotics adoption often includes significant upfront investment costs, which can be prohibitive, especially for small and medium-sized enterprises (SMEs). The emergence of RaaS models shifts this narrative by allowing businesses to access robotic automation without substantial initial capital. This model not only democratizes access to advanced robotics but also reflects a broader trend where industries are adapting to technological advancements through flexible financial solutions. It counters the presumption that robotics are exclusively for large enterprises with deep pockets. For addressing labor shortages with automation, there is a common belief that automation leads to job losses. However, the reality in many sectors is that robotics are being utilized to address critical labor shortages rather than replace human workers outright. The integration of robotics allows human employees to shift focus from monotonous or hazardous tasks to higher value activities. This counterintuitive perspective highlights a potentially positive outcome of robotics, where they serve as a solution to demographic challenges in labor markets rather than merely a replacement for human labor. 5. Rapid adoption driven by crisis response. While crises typically result in economic downturns, the current trends suggest that recent global challenges are accelerating the adoption of robotics across various sectors. This is counterintuitive because one might assume that economic instability would hinder investment in new technologies. In reality, the urgency to improve supply chain resilience and production capabilities in response to recent crises is driving businesses to embrace automation and robotics at an unprecedented pace. 6. AI integration enhancing human roles. The integration of AI and robotics is often viewed as a means to reduce human involvement in various tasks. However, the use of AI is also enhancing the capabilities of human workers by providing them with tools that enable better decision-making and efficiency in their roles. This duality presents a counterintuitive outcome where AI not only replaces certain functions but also amplifies human potential, thereby transforming the workforce rather than diminishing it. 7. Emerging industries beyond traditional manufacturing. The notion that robotics are limited to traditional manufacturing sectors is being challenged by the expansion of robotics into new fields such as healthcare, agriculture, and logistics. This expansion is counterintuitive because it suggests that the potential applications of robotics are far broader than previously understood, opening up new markets and opportunities for innovation that go beyond conventional industrial settings. In conclusion, the anticipated disruption driven by robotics and automation reveals several counterintuitive insights that redefine how we understand the intersection of technology and industry. From the focus on single-purpose robots to the role of automation in sustainability and labor dynamics, these findings emphasize the complex and often surprising ways in which robotics are reshaping the global economy. The anticipated $10 trillion market disruption across manufacturing, logistics, agriculture, healthcare, and retail by 2030, propelled by advancements in robotics and automation, marks a significant turning point in multiple industries. While most analyses tend to focus on broad trends and overarching benefits, several critical aspects within this context are often overlooked. Below are some of these insights along with explanations of their significance. 1. The role of AI in robotics. While many reports emphasize the integration of AI in robotics, the nuances of different types of AI, analytical, physical, and generative, are frequently understated. Significance. Understanding these distinctions is crucial because they dictate how robots will be deployed across various sectors. Analytical AI enhances decision-making through data processing, which can lead to improved operational efficiency. Physical AI allows robots to learn from simulated environments, increasing their adaptability and effectiveness in unpredictable real-world scenarios. Generative AI could revolutionize training methodologies, enabling robots to develop new skills autonomously. This differentiation is vital for businesses to assess the suitability and readiness of robots for specific tasks within their operations. 2. Economic viability of humanoids. The media often sensationalizes humanoid robots, presenting them as the future of robotics. However, the current focus on single-purpose robots and industrial applications is often overshadowed in discussions. Significance. This emphasizes a critical economic consideration. While humanoid robots capture the imagination, their practical applicability and cost-effectiveness in industrial settings remain questionable. Companies must weigh the investment in humanoid technology against proven solutions that meet immediate operational needs. This assessment could prevent misallocation of resources and ensure that investments are directed toward technologies that deliver tangible returns. 3. Sustainability efforts beyond compliance. The reports mention the role of robots in meeting UN sustainability goals, yet they often overlook the broader implications of these initiatives. Significance. As corporations increasingly face public scrutiny regarding their environmental impact, the adoption of robotics not only aids in compliance but also enhances brand image and competitive advantage. Companies that proactively invest in sustainable robotics can differentiate themselves in the market. Moreover, the potential for robotics to contribute to the circular economy, where waste is minimized and resources are reused, can lead to new business models and opportunities. 4. Robot as a Service RaaS model. While the robot as a service model is mentioned, the transformative potential of this business model is often underexplored. Significance: RaaS democratizes access to advanced robotics, particularly for SMEs that might otherwise be priced out of automation. This shift can accelerate the pace of automation across sectors, leading to a more inclusive economic landscape. By allowing businesses to scale operations without heavy initial investments, RaaS can catalyze innovation and agility within industries, fostering a more dynamic economic environment. 5. Labor market dynamics. The reports highlight labor shortages as a driving force for the adoption of robotics. However, the implications of this trend for the workforce are often glossed over. Significance: the introduction of robotics can lead to significant changes in workforce dynamics. While automation can alleviate labor shortages, it may also displace workers in certain roles. This necessitates a strategic approach to workforce development, including reskilling and upskilling initiatives. Companies that proactively engage in workforce transition strategies can mitigate potential backlash and enhance employee loyalty and productivity. 6. Sector-specific challenges and opportunities. Different sectors have unique challenges and opportunities in adopting robotics, yet many discussions tend to generalize across industries. Significance: a tailored approach to robotics implementation can yield more effective results. For example, the healthcare sector faces stringent regulatory requirements, making the integration of robotics more complex but also potentially more rewarding in terms of patient outcomes. In agriculture, robotics can address labor-intensive tasks, but the technology must be adaptable to varying environmental conditions. Recognizing these sector-specific intricacies can enable companies to craft more effective strategies for automation. 7. The psychological aspect of automation. While the reports focus on technological and economic factors, the psychological impact of automation on the workforce is often overlooked. Significance: the introduction of robots can create anxiety among workers regarding job security. Addressing these concerns through transparent communication and involvement in the transition process can enhance buy-in and reduce resistance. Companies that foster a culture of innovation and inclusivity may experience smoother implementations of robotic technologies, ultimately leading to greater overall success. 8. Global disparities in robotics adoption. The anticipated disruption is discussed primarily within developed nations, with little attention given to global disparities in robotics adoption. Significance: understanding that developing regions may lag in robotics implementation due to various factors such as economic constraints, lack of infrastructure, or skills gaps, can inform strategies for global market entry. Companies looking to expand internationally must consider these disparities to tailor their approaches, ensuring that they can effectively tap into emerging markets while supporting local development. Conclusion: the projected $10 trillion disruption across key sectors by 2030 is not merely a technological shift, it represents a paradigm shift that requires nuanced understanding and strategic planning. Recognizing the often overlooked aspects of AI integration, economic viability, sustainability, labor dynamics, sector-specific challenges, psychological impacts, and global disparities is vital for stakeholders seeking to navigate this transformation successfully. Embracing these insights will enable businesses not only to adapt but also to lead in a rapidly evolving landscape shaped by robotics and automation. 1. Technological innovation in robotics. The integration of advanced artificial intelligence (AI) technologies is crucial in driving the next wave of robotics. The use of analytical, physical, and generative AI is transforming how robots perform tasks across various sectors. Analytical AI enhances robots' ability to process and analyze large datasets, allowing them to adapt to unpredictable environments. Physical AI enables robots to learn from simulated environments, thereby improving efficiency and autonomy. Generative AI is set to revolutionize the robotics landscape by creating advanced simulations that enhance training and operational capabilities. This technological evolution not only boosts productivity but also opens new applications for robotics in areas like healthcare and agriculture, where precision and adaptability are paramount. 2. Sustainability and energy efficiency. The push towards sustainability is reshaping the robotics industry. As manufacturers face increasing pressure to meet environmental goals, robots are emerging as key players in enhancing production efficiency while minimizing waste. Innovations such as lightweight materials and energy-efficient designs are making robots more sustainable. The ability of robots to consistently produce high-quality outputs reduces resource wastage and promotes sustainable manufacturing practices. Moreover, robots are critical in the production of green technologies, such as solar panels and electric vehicle batteries, highlighting their role in supporting the broader transition to a sustainable economy. This trend aligns with global efforts to address climate change and could significantly influence how industries operate moving forward. 3. Emerging business models, Robot as a Service RaaS. The introduction of RaaS models is a game changer for the adoption of robotics, particularly among small and medium-sized enterprises (SMEs). Traditional ownership models often present high upfront costs and maintenance burdens, deterring many businesses from investing in robotic solutions. RaaS allows companies to access robotic capabilities without substantial capital investment, democratizing automation and making it accessible to a broader range of industries, including construction and logistics. This shift not only encourages innovation and flexibility but also enables rapid scaling of operations, crucial in a fluctuating market landscape. As companies increasingly recognize the value of automation, RaaS could lead to significant growth in the robotics sector and reshape competitive dynamics across various industries. 4. Addressing labor shortages. The global economy is grappling with significant labor shortages, particularly in manufacturing, due to demographic shifts and changing workforce dynamics. Robotics offers a viable solution by automating repetitive and hazardous tasks, thereby allowing human workers to focus on higher value activities. The rise of collaborative robots, cobots, and mobile manipulators is facilitating this transition, enabling seamless integration of robots into existing workflows. By addressing labor gaps, robotics not only helps maintain productivity but also enhances workplace safety and job satisfaction by offloading undesirable tasks from human workers. This trend underscores the importance of robotics in sustaining economic growth and addressing critical labor market challenges in the coming years. In conclusion, the anticipated $10 trillion disruption across key sectors by 2030, driven by advancements in robotics and automation, presents a transformative opportunity for industries to enhance efficiency, sustainability, and productivity. Companies like Tesla are well positioned to lead this shift, leveraging technological innovations and emerging business models to capitalize on the evolving landscape. 1. The Industrial Revolution, late 18th to early 19th century. This period marked a significant transformation in manufacturing processes, primarily in Britain, as industries shifted from hand production methods to machines. The introduction of steam power, mechanized textile production, and the establishment of factories led to unprecedented efficiency gains and economic growth. The Industrial Revolution not only disrupted traditional labor markets but also catalyzed urbanization, changing societal structures and the global economy. 2. The dot-com bubble, late 1990s to early 2000s. The rise of the internet and technology companies during this period led to a massive disruption in various sectors, including retail, media, and telecommunications. Companies like Amazon and eBay emerged, fundamentally altering consumer behavior and the retail landscape. Despite the eventual burst of the bubble, which resulted in significant financial losses, the innovations and business models that developed during this time laid the groundwork for the modern digital economy, emphasizing the power of technology and automation in reshaping industries. 3. The automation of agriculture, 20th century. The introduction of machinery such as tractors, harvesters, and advanced irrigation systems revolutionized agricultural practices. This transition from manual labor to mechanized farming techniques drastically increased production efficiency and crop yields. The shift not only changed farming practices but also altered labor dynamics in rural areas, leading to urban migration and the rise of agribusiness, demonstrating how technological advancements can disrupt traditional sectors and create new economic paradigms. The future outlook for the anticipated $10 trillion market disruption across manufacturing, logistics, agriculture, healthcare, and retail by 2030 is marked by transformative changes driven largely by advancements in robotics and automation. This disruption is projected to deliver efficiency gains of around 25%, positioning companies like Tesla as leaders in the evolving global robotics landscape. Key predictions. 1. Technological advancements in robotics. The integration of advanced artificial intelligence (AI) will revolutionize the capabilities of robots. Technologies such as analytical AI, which processes data for optimal task management, and physical AI, which simulates real-world environments for better operational training, will become commonplace. Generative AI is predicted to enhance the adaptability of robots, allowing them to learn from diverse scenarios and improve their functionalities autonomously. This will lead to more efficient operations across various sectors. 2. Dominance of automation in industry. Automation will increasingly dominate manufacturing, logistics, and agriculture, with robots performing a wider range of tasks from assembly lines to farming operations. This shift will help companies reduce costs, increase production rates, and meet the growing consumer demand for efficiency and speed. The automotive sector will continue to be a front-runner in adopting robotic technologies, paving the way for broader acceptance in other industries. 3. Rise of humanoid and collaborative robots. While humanoid robots are gaining media attention, their practical applications will likely remain limited to specific tasks within controlled environments such as logistics and customer service. In contrast, collaborative robots, cobots that can work alongside humans, will become more common, enhancing productivity and safety. Businesses will adopt humanoid robots primarily for tasks that require human-like dexterity, but the economic viability of these robots will need further validation compared to existing single-purpose automation solutions. 4. Sustainability and energy efficiency. The push for sustainability will drive the design and deployment of energy-efficient robots, contributing to broader environmental goals. These robots will be crucial in minimizing waste and enhancing the sustainability of production processes across industries. Innovations such as lightweight materials and smarter energy management systems will ensure that robots not only support production efficiency but also align with global sustainability initiatives. 5. Emergence of new business models. The traditional barriers to adopting robotic solutions, particularly for small and medium-sized enterprises (SMEs), will be alleviated through models like Robot as a Service (RaaS). This will allow companies to access advanced robotic technologies without the burden of large capital investments. New market segments, including construction and warehousing, will emerge as significant adopters of robotic solutions, driven by the need for operational efficiency and resilience in supply chains. 6. Addressing labor shortages. As demographic changes lead to labor shortages in developed economies, robotics will play a critical role in bridging the gap. Automation will take over repetitive and hazardous tasks, enabling human workers to focus on more complex and value-added activities. Collaborative robots will become essential in environments where labor shortages are acute, facilitating a smoother transition for industries adapting to these changes. 7. Market dynamics and competition. Major players including Tesla will lead the charge in innovation and deployment of robotics, positioning themselves as key contributors to the $10 trillion market disruption. This competition will drive rapid advancements in technology and operational efficiencies. Startups and established companies alike will explore niche applications of robotics, creating a diverse ecosystem that caters to various industry needs. 8. Healthcare innovations. The healthcare sector will witness a significant impact from robotics, particularly in areas like patient care, surgical assistance, and logistics within hospitals. Robotics will enhance precision and reduce the risk of human error, ultimately improving patient outcomes. Automation will also streamline administrative processes, allowing healthcare professionals to dedicate more time to patient-facing activities. 9. Integration of robotics in retail. Retail will evolve with the integration of robotics in supply chain management, inventory tracking, and customer service. Automated systems will optimize logistics and enhance the shopping experience through personalized services. The shift towards e-commerce will drive the demand for efficient robotic solutions that can handle increased order volumes while maintaining service quality. Conclusion: the convergence of robotics, AI, and automation across key sectors is set to redefine operational paradigms by 2030. The anticipated $10 trillion market disruption will not only yield significant efficiency gains but also foster innovation and sustainability. Companies like Tesla, with their commitment to advanced robotics, will play a pivotal role in shaping this future, leading to enhanced productivity and a more automated economy. As industries adapt to these changes, the focus will be on leveraging technology to overcome challenges, enhance efficiency, and meet the evolving demands of consumers and businesses alike.